In this video, I want to introduce the idea of the ordered symbol table API. We'll also do a little bit of an example with it as well. So this is an extension that we talked about before. In a previous video, we discussed symbol tables just as this plain API, which basically just had get, put, delete, and a few other helper things, right? They were very typical of pretty much any ADT or collection that's out there. Now, the thing we're introducing here is kind of this more complex or advanced type of symbol table, right? This is called an ordered symbol table. The idea of an ordered symbol table is that the elements within it have an order. And we can see it over here in this diagram. So over here, notice we have this signature here. It says ST key extends comparable key value. Notice that there's some new stuff here. Over the previous example, we now have this stuff here. Key extends comparable of key. So what that's saying is now we have a symbol table where the only stuff I can add to it is stuff that's comparable with itself. It's a little bit like the sorting constraint. So if you think back about sorting, those functions, right, those things that we had worked with, basically all of those required us to have, this comparable, like whatever it was, right, it had to be an array of comparables because that gave us enough flexibility that we could actually tell what order things go into. So now this is what we're kind of requiring, right? We're requiring our symbol table, or having a symbol table, right, require us to store stuff in it, right, that is comparable in some sense, right? There has to be some sort of compare to available for us. And when we do that, we basically get a whole bunch of other functions. So we're going to add a whole bunch of stuff. So the things that are new are basically these things on the bottom. So this stuff here is all new. The other stuff is ones that we had in the previous example, right? The normal symbol table. So let's take a look. What can we get if we all of a sudden require that our symbol table only stores things that are ordered? Well, first of all, we get min and max. So what we're saying now, right, is our symbol table, we have the ability to pull out the smallest thing, pull out the largest thing. Right? And this is kind of nice. If we had something like an array, we kind of get some of this, out of the box because, like, wow, what is that index 0? What is it index 100? Right? I can do that, very easily. Here, I don't know, right? I don't know what keys are available to me. So this is going to be helpful, right? I have the ability all of a sudden to find that smallest element, to find that largest element. So that's kind of cool. So we have those two. Next thing we have is floor. So here's kind of an interesting thing. Actually, it applies basically to both floor and ceiling. These two are basically like inexact operations. So the idea is you have your symbol table, and your symbol table has a bunch of values in it, right? And we'll go through an example in the next slide that will make this a little bit more clear. But just to get you guys started, is just imagine you have a symbol table that has a bunch of values in it. I'm just going to imagine these are actual numbers, not just like slashes or something. Well, actually, I got it. So imagine I have a symbol table has values like in an increasing order like this. Imagine these are all like the same height here. What you can do is you can do things like basically give the symbol table a key and then say what is the floor of it. And if you say what's the floor of it, it'll basically go and find it's like okay if that key existed in your table it would have been say over here, but it's like hey it didn't. Well, if you do the floor command, basically what it does is it looks up what is the key that is either the thing you're looking for or the thing just before it. Okay, ceiling looks up your key or the thing just after it. So the idea is, right, instead of picking out this one exact element, right, because typically what we do is we say, okay, do a get on this thing, right, and I get back that one value. Sometimes, right, you're in a situation where it's like, I don't know what is the nearest key to this location that I want. Well, I'll just use a floor or ceiling. It'll jump to that location, right? It tries to look there first, and if it's not there, either goes to the thing underneath or the thing above it. That's where the terms floor and ceiling come from. So these are kind of a little bit more like imprecise way somehow of getting data. And you'll see this in a few minutes, right? Once we get to kind of a little bit of a simulation of this thing. So yeah, those two are kind of neat. All right, so those two go together. Rank and select go together as well. Rank and select is kind of funny to me. So rank and select are basically because the description sounds weird here. But rank and select are basically our methods for accessing items with the base 0 index. So let's say I have an array. Let's have an array with, I don't know, 4 slots. 0, 1, 2, 3. Imagine I have A over there in slot 3. So notice, right, that I have over here, I have rank. So rank's description is number of keys less than key. So if I do rank of A, what happens is I get the number 3 because there's 3 things before it. Okay, so rank of A would return 3. Okay, it should be rank of A, not rank of 3. Rank of A gives me back 3. Okay, so it's like if you imagine an array under the hood, giving me back the index of where it's stored. Select is basically the opposite. So it's saying that select is saying key of rank K. So it's like if I do select of 3 it gives me the element with 3 things underneath it, which would be A here, right? There's slots 0, 1, 2 are underneath it, okay? So key and rank together are basically just giving you a way to do index 0 references into your data. So normally, right, that's how arrays work, right? If I have my bracket notation, it's like, give me, thing at index 3. That's exact same here as doing selective 3, right? It gives me that element that has 3 things underneath it. By the fact that arrays start at index 0, that means basically I'm just, doing an array index now. And rank is a little bit new because it's giving us basically the idea to find out what that base index 0. Rank is giving me the ability to find the base. Rank is giving me the ability to find the index of something in a base 0 situation, right, where things start at 0. So it's kind of like the inverse operation of selecting something that's in there. So yeah, those are basically just for making a handle like an array. All right, moving along, delete min, delete max. So those are just min and max, but we're going to remove it, right? Instead of just previewing them or seeing what's going on. The next thing here, right, is I have size and keys, and these are kind of interesting because the parameters are more complicated. All of a sudden, I have low and high. So what these 2 things are now doing, right, size and keys, and we've seen the simple versions before, right? And the simple versions basically were like size. Like size just told me how many elements were in the entire thing, right? Keys gave me all the keys that are out there. Now we have this additional constraint where we're basically saying how many keys are between these 2 endpoints. So it's like I have a low, I have a high, give me the stuff in between, right? So that's the keys I'm going to return. Those are the keys I'm going to count and return in size. So you're kind of constraining yourself to an interval of all the keys that are actually in that symbol table. Okay, so it gives you a way kind of to focus on some little subregion. All right, so this is kind of our overview here, right? This is our API. Again, right, all this stuff in the red box is brand new. So we have a little bit of idea how this stuff looks. Let's take a little look at a bit of a trace for this thing. So here we have some data. So this data is now a little bit more interesting than we had before. We have basically is times and locations, right? So times are our keys, our values are locations. So let's take a look. We can kind of just walk through here, right, kind of from top to bottom. So let's see, min. Well, we'll jump around a little bit, I suppose. Min, right? Basically, it's like so. This is our data, right? This is our data. If we were to run min on this, it returns the first time, right? The lowest thing, 9 a.m. We're in a max. Returns the highest thing, right? 937.44. Okay, min and max. A get of 90013. Well, 90013 exists in my table. That's linked up with the value Houston, so it returns Houston. Okay, pretty good. All right, and now we have something a little bit more interesting now. Floor 90500. There is no 90500 in my data set. So what happens? It goes and it grabs the thing just underneath it. So floor returns actually 90313, right? That's the closest thing under that point that I actually did want. So it returns this value over here, right? It returns this thing over here. So yeah, that's our floor. Let's look over at ceiling. See something similar. So ceiling of 930. Well, I don't have a 930. What's the thing that's kind of right after it? 935.21, right? To Chicago. I'm assuming these are like a list of flights is what I'm visualizing these as. Although this is pretty like. I guess you have 2 flights to Chicago 10 minutes apart. That's maybe a little bit iffy, but I always visualized them as being like flights. So yeah, you don't have that 930, so you go for the thing just above it. That's the 935.21. Okay. So we have ceiling, we have floor, then we have select. So select of 7. I basically told you that was something that looked like an array index lookup. So let's suppose for a second this was stored in an array. What would the indices look like? Let's say I have 0, 1, 2, 3, 4, 5, 6, 7. So notice that, right? If these are an array, that element there I would look at, right? What the notation here is saying is that if I do a select of 7, it's going to return to me the 9, 10, 25 to Seattle. That thing, right, would be stored at that index 7, right? So I'm looking up, what is that element? What is the thing in my symbol table that has 7 elements less than it, right? Which corresponds to that base 0 index. So yeah, that's my select operation. Let's see. The last one here that's kind of cool is this keys. So keys 915 and 925. Notice again, right? It's basically looking at the table and picking an interval. So it's like, what is between these 2 times? Well, I'm going to start basically with my 919, 32, and then I'm going to go to my 922, 54. So that's things that fit into my little interval I've defined there, right? My little 10-minute interval. So yeah, it would basically return all those keys in there, right? Those 5 different keys, it would return them. The other 2 examples here are really, they're similar to stuff we already have here, so there's not a big deal. So rank of this one time over here, right? So rank of this, right, is obviously 7, right? The rank of any of these, right, is basically what would their index be in a base 0 array. And then size, right? Size of keys, right? It's like, well, keys captured 5 things in the interval. Size naturally has to return 5, right? Because there was 5 things in there. So yeah. So you have size, we have key, we have rank. All right. So that's kind of an overview. As a quick just note about how syntax would look a little bit like this. So if I wanted to actually use an ordered symbol table, I could do something here. This is pretty simple. What I have here is kind of a visualization of, imagine, right, you have a bunch of flights to a different location. This is one. Trying to remember, this is for one trip I took. I'm trying to remember SEL. I don't remember, is that Seoul? Yeah, it is. That was a planned trip to Korea that didn't happen that year. It happened another year. But anyways, you can have here basically, right, you imagine you have all your flight data, right? So it's like you have a symbol table, you populate it with your 5 different flights, right? Just throw everything in there. All of these, right? Somehow, right? Your flight over here, right, is a custom object. That object has to support comparable, right? It's because you need to compare to, right? We need to be able to see what order things are in. And then over here, we can do things like this. Prices.keys 0 to 850. What that's basically saying is, give me all the flights that cost less than 850, okay? And it gives me all different choices. So this is a little bit, right, like your favorite deal cipher flights, right? So it's like you can probably put in an upper limit to say something like, okay, give me all the flights less than this money, right? And as you do the lookup, it's roughly equivalent to this, right? Saying that I have this big pool of data, give me that slice of things in this interval, right? So that's what you get from keys, right? Keys has the ability, right, to give you that slice of your entire collection, right? Your entire collection has everything, but it's like, well, some stuff is so expensive, right, that doesn't even count. Just give me the stuff between here. So yeah, then we would basically get our list of all the flights. They're up to 850, right? We could print them out, look at them, try to figure out which is going to be the best one. So yeah, that's what we have here, right? Quick little example. So we spent a few slides here. I talk about ordered symbol tables, right? Hopefully you guys have some idea of the concept of them, some of the operations that they support. Later on, right, not right now, but later on, we will talk about the implementation, because the implementation is a little bit tricky. Normal symbol table is pretty straightforward to implement. Ordered table obviously takes a little bit more work.